We can write rules in different ways. For example, we can write a rule for the distance biked after doing a 4-mile warm-up and then speeding up to 12 miles per hour. We can make a table. When we finish our warm-up ride, we've already gone 4 miles. After 1 hour of biking at 12 miles per hour, now we've gone 12 more miles. After another hour, we've gone 12 more miles. And after 1 more hour, we've gone 12 more miles. So we start our main bike ride having already gone 4 miles, and then each hour we go 12 more miles. We can write this rule as an equation. We've already gone 4 miles, and then we go 12 miles for every extra hour. Where x is the number of hours, and y is the number of miles. We can make a graph for the rule. After 0 hours, we've already gone 4 miles. After 1 hour, we've gone 16 miles. After 2 hours, we've gone 28 miles. And after 3 hours, we've gone 40 miles. It makes sense here to connect the dots, because we're constantly riding our bike. We can even make a diagram. When we start our main bike ride, we've already gone 4 miles. After 3 hours, we've gone 40 miles. And after 2 hours, we've gone 28 miles. This rule is called a function because none of the inputs have more than one output. In this lesson, you will learn a method for determining whether a rule is a function based on its graph. Let's determine if this relation is a function. Remember, if it's a function, each x can be used no more than once. We see that 4 has 2 different outputs. So this relation is not a function. Let's see how this looks on the graph. We notice that the inputs with more than one output have points that line up vertically. Here's one for you to try. Is y equal 3 a function? Notice that the graph is a horizontal line. The graph shows that this relation is a function. No x matches with more than one y. When x is 2, y is 3. When x is 0, y is 3. When x is negative 2, y is 3. You can move a vertical line from left to right on a graph to determine if a graph is a function. If the vertical line never intersects the graph more than once, you know that none of the x values have more than one corresponding y value. So the graph is a function. This test is so handy, they gave it a name, the vertical line test. If all possible vertical lines cross the graph once or not at all, then the graph represents a function. The green vertical line is only intersecting the graph at most once. So this graph is a function. If the line intersects the graph more than once, then the graph does not represent a function. We notice here the green vertical line sometimes hits the red graph more than once. So the graph does not represent a function. Here's a question where you can use the vertical line test to help you. This relationship is a function because any vertical line crosses the graph only once. Here's another one. This relationship is not a function. We see the vertical line hits the graph more than once. Here's an interesting graph, but does it represent a function? Once again, this graph does not represent a function because in some places the green vertical line hits the graph more than once. Here's something a little bit different. We need to draw a graph so that the domain uses x's between -2 and 4. And the range uses y's between 0 and 5. Let's give it a try. So my x's need to stretch from -2 to 4, and my y's need to go from 0 to 5. So I'll just pick a starting spot at -2 for the x value. Why don't we go up to 5 for the y value? As we make our way right, we'll drop down to 0 for the y value. So now we have y's going from 0 all the way up to 5. But we still need to get x's all the way over to 4. Looking at the x-axis, this graph goes from -2 to 4. So it has a domain with x's between -2 and 4. Looking at the y-axis, this graph goes from 0 to 5. So it has a range with y's between 0 and 5. In this lesson, we represented functions with equations, graphs, diagrams, and tables. We also used the vertical line test to see whether a graph represents a function.